Alright folks, this will be a very short video just reviewing stuff from acids and bases, which you learned about last year in Mr. White's class or wherever you had for 8th grade physical science. And you know the basics of these in order to do well on the pH lab that we'll be having next time I see you. So you may remember from physical science learning that there are a few different definitions of an acid. The definition that I like to use, and I think most scientists have sort of settled on, is that an acid is any substance that when you put it into water will release H plus ions. You need to know that, ladies and gents. A base, on the other hand, is a substance that releases hydroxide or OH minus ions when placed into water. So a classic example of an acid would be something like HCl or hydrochloric acid. When I put that into water, it completely disassociates or breaks up into H plus and Cl minus. And so of course, because it releases the H plus, it is considered an acid. A base that you may or may not have heard about is sodium hydroxide, NaOH. It's considered a base because when you put it into water, it breaks down completely into Na plus and OH minus. So it is considered a base because, critically, it releases the OH minus or the hydroxide ions. So that's what makes an acid and a base. Make sure you know those definitions for sure. The pH scale is hopefully something you remember from your 8th grade physical science. pH scale essentially was developed to describe or kind of sort and organize the acidity or the basicness of whatever solution it is we're talking about. How it's set up, we don't have to get into all the nitty-gritty details, but you do need to know the critical thing: neutral is pH 7. So that's important for you to know for sure. 7 is neutral. As we go from neutral, if the pH number is larger than 7, we are getting increasingly basic. If we're going lower than 7, as we go from 7 down to 0, we're getting more and more acidic. So very, very acidic things like battery acid, very, very basic things like sodium hydroxide are on the far end, 14 and 0. As we get closer to 7, we're getting less and less acidic, less and less basic, more and more neutral, like our blood, tears, pure water is neutral. Now, a question that you might have on an exam, for example, would be something like, which of these solutions has more H plus ions in it? Stomach acid or tomatoes? Well, if you look at the two, stomach acid is very, very acidic, so you're going to have lots and lots of H plus ions. Tomatoes, not as acidic, so you're not going to have as many H plus ions. So clearly stomach acid has more H plus ions than the tomatoes. This may be the only new word that you've never heard before. At least, I don't know if you mentioned it so much in physical science, but a buffer. Buffers are actually very, very cool. We're not going to get into all the details, but they're weak acids or weak bases. And what's important about them is that they actually prevent sharp changes in pH. They keep the pH of a solution stable. And our body uses numerous buffers to maintain a stable pH right around neutral. And actually all living things have buffers in them they manufacture that help keep their pH whatever pH they're supposed to be. Now if you think about that, what is that an example of? We're talking about a living thing maintaining its stable, right? That's an important word, stable internal environment. What is that? That of course is homeostasis. Right? So make sure you make a little note that that is homeostasis somewhere down here in your notes. Alright folks, hope this helped review acids and bases for you. I will see you next time for the lab on pH.